Yeah. Uh, Good morning. Hello all. Welcome to my channel. Today we'll discuss about EVST to electric vehicle, how this communication will happen, and we'll discuss about the control pilot and proximity pilot PLC in this video. So we'll start. So here, this is the one electric vehicle charging station. Okay, here electric vehicle, here one male connector here, and here one wire cable with female connectors. In between this connection, what and all it will be there. So one is power supply, other AC or DC, and one more pin is CP, control pilot, one is PP, proximity pilot. So now, what is the use of this control pilot and what is the use of this proximity pilot? First we will discuss about proximity pilot. Okay, so here normally this is the EVSE, right? So normally in our electric vehicle, one gateway board will be there. So here one resistors logic with 5 volts, and here one resistor ground connecting to ground. It will go to our MCU. No, here one op-amp circuit will be there, so that will go to our MCU. Now this is the one connector. Okay, this side these two grounds are same only. Okay, so sometimes this point will go to, sometimes some of the EVC stations will measure this point, otherwise they won't measure it. Okay, whenever it is connected, right? So before connecting this connector, normally with these two resistors R1, R2 divided network, one voltage will generate here. Once when this connector is connected, so normally some of the charging stations, this switch will close, then only one resistor, this resistor only will coming to picture. Some charging stations, these two resistors will be there. So now we will consider only one resistor. So here this R3, whenever this connector is connected properly, R2 and R3, this 2 is parallel to versus R3. So then again here voltage generation rate, it will change, it will reduce to some value. Okay, so again after that, so it is properly connected. Why it is required means, whenever the charging station is connector is properly connected or not, to verify this EV electric vehicle verify through this PP line. Then after that, once it is verified, then now properly it is connected, then it will go to CP. How it will be there? So there is a one in EV electric vehicle station, 3 types of supplies. One is 12 volts, one is PWM, and one more is minus 12 volts. This type. First initially one resistors will be there. It is connecting to, and this end it will connect to EVSE, and this side one diode, and here one resistor, here one resistor, one switch. This end will go to the EV electric vehicle. Now initially 12 volts will connect. Whenever it is connected 12 volts, here before connected properly, this connector before it, here it will be 12 volts. So that time EVSE will decide there is no connection in between the EVSE and EV. Whenever it is connected properly, this 12 volts will flow this way via this ground. Okay, here it will generate 9 volts. We should have to arrange these resistors. R1 and R2. Okay, once when this 9 volts will appear here, before that here 9 volts will appear. So this EVSE will measure this 9 volts. It will decide that properly connected, then it will shift this 2 volts to PWM. Here PWMs will generate 9 volts of PWM plus or minus. Okay, so whenever the PWMs observed here, this will measure the duty cycle of this PWM. It means, what is mean of this duty cycle? It means normally that EVSE charging stations, it will generate different type of duty cycles percentage, 10% and 20% and 30, 50, 53. It means that each percentage have the each current rating. Okay, means normally how will calculate this means duty cycle is equal to maximum rating of this current by 0.6 times. Okay, whenever if we fix a duty cycle means, for example 53% into 0.6 is equal to how much? 8, 1, 15. 15 means 30, 1, 8 and 30, 31. So nearly 32 amps current rating capability. Okay, like this it will, the EVSE capability wise this PWM will generate. So once this EV electric vehicle read this PWM, this internal EV electric vehicle will decide whether internal onboard charger is capable to that current rating or not. Once if it is confirmed, yes, it is capable to charge, it means it will generate one signal to this switch. It will this switch will close, then these two resistors will parallel, then automatically this across this voltage will be 6 volts. Like that we have to decide it as per the standards. Okay, once when this 6 volt, when this here 6 volts is generated, EVSE will decide, EVSE will get the confirmation from the electric vehicle to charge, to start the supply to the electric vehicle. So it will start the supply to electric vehicle. Internal onboard charger will start to charge this internal onboard charger battery. So this is the process of electric vehicle in CP and PP. Okay, next here like this, here this is the proximity. Earlier I have explained it, right? In standards they have given it entire circuit with respect to this voltage levels also. Okay, this is the note section. This is not mandatory. Some of the EVSE stations will measure this voltage levels. Normally this is the proximity electric vehicle side, and it is going to the microcontroller. Here this is the connector pins. Once this, whenever this inserted, so it will both will insert. Okay, both when this grounds both is connected properly, then only here voltage will change, then only that PP electric vehicle and EVSE will decide properly it's connected. This is the proximity working. Okay, whenever go to this control pilot, this is the control pilot. Okay, here this is the control pilot circuit, this is the EVSE, this is the electric vehicle. Okay, this is the 12 volt supply PWM, plus or minus 12 volts and minus 12 volts. Okay, first initially it will connect to 12 volts. So earlier I explained it, right? It will flow via this resistor first initially. Once 9 volts is generated, that this 9 volts will measure this EVSE as well as EVSE as well as EV. Okay, like this. So again it will shift to, once it is got 9 volts, again it shift to 9 PWM, again it will trigger this switch and it will start communication. This is the process of control pilot. Okay, so going here, this is the different state of state A, state B to state A to state F. It means state A, it means that vehicle is not connected. It means there is no connection in between. There is no connection. This connection is not there. Then how what will be there? Here 12 hours. Here 0. Right. This means state A. State B. State B, it means state B, it means this is connected. Whenever it is connected, right, it will generate 9. But here it will measure 9 volts. Here it will measure 9 volts. But what it will decide it? This 2 is connected, but there is no current flow because it is 9 fixed 9 volts, right? Again, next stage it will shift to, it should generate PWM and send to the EV. Then only it will decide capability of EVSE. Okay, that this is state B. Now it's connected. It's dropped to from 12 volts to 9 volts. In state B1, it dropped to 12 volts to 9 volts. In state B2, what will happen, right? Here, whenever the EVSE is measured 9 volts, immediately the 2 volts connected to the 2 volt switch, S1 switch is connected to PWM. This is the state B. Once the PWM generated, here PWM circuit will generate. Okay, this is the state B2. Okay, state B2, vehicle connected, not ready to accept energy. In between, its communication is happening, but there is no acceptance permission to supply to electric vehicle. Next stage, in state C. Now once 9 volts, whenever the 9 volts observed in EV, this PWM with respect to PWM circuit, here what will happen? Again, it will measure the current rating capability inside onboard charger. Once it is confirmed, it will trigger this switch. So once it's triggered, it will go to 6 volts. This is the state C. Whenever it is triggered says 6 volts, it means that vehicle is connected, ready to accept the energy. Electric vehicle is accepted to transfer the energy battery. So, and also indoor charging area is there. That charging area is not required any ventilation. If 6 volts, it means if it is generated 6 volts. If in state D, it means if EV generated 3 volts, it means accept indoor charging area ventilation is required. EVSE capable to supply energy. Okay, in state E, next here in state E, if here if any 0 was here and here, if any 0 was generated, it means internal internal this pin will shorted to ground. So due to that, it was generating 0 volts. It means this is the state E. State E means EVSE disconnected from vehicle, EVSE disconnected from utility, EVSE lost from utility, or control pilot short to ground, short to control pilot reference. Okay. State F, it means internally. Now normally first time 2 volts, again it will connect to PWM. Here minus 2 volt also is there, right? When this 2 volts will connect, minus 2 volts means internal EVSE, any issue if it is there in while charging time or any time, if it is connected to minus 2 volt, it means that internal EVSE has a problem. So here it will decide there is a problem, so no need to command it. So this is the state F. So this is and all state of state A to state F communication. Okay. Now we'll go to next. Here normally this is the PWM power line communication, pilot wire communication which is happening. Normally pilot wire communication for AC, normal AC charging stations, it is okay. But if you want it AC smart charging, AC smart charging or DC fast charging, it means there is a one more communication, high level communication is required. That is the PLC communication. PLC communication is nothing but as power line communication. PLC is nothing but power line communication. Okay. Okay, PLC. PLC, it means that how it will work. It means power line communication is normally will generate the frequency from 1 megahertz to 30 megahertz frequency. How it will generate? For example, first frequency, one frequency cycle. Next data will be one more frequency cycle, like this. Okay, like data it will generate different way. Okay, this is what is the advantage in from the earlier pilot wire communication to this one, right? Normally pilot wire communication will transfer the capacity of this side and this side only, so it won't transfer the data from EVSE side. This is the EVSE, this is the EV. Normally in pilot PLC, it means bidirectional communication as per the standards in smart grid DC fast charging station, that and all bidirectional communication it should be there required. Normally PWM's communication, it means only one-way communication only. There is no data transfer in between these two, EVSE and EV. This PLC, and also it will transfer the both sides, whether for example in EVSE from grid, the grid in any issue is there in grid, so it will transfer data to the EV. There is an issue in grid, you can drop your power charging capability, so it will EV will drop the charging capability. Okay, then and also sometimes EV will transfer the electric vehicle transfer the battery SOC condition. So in for smart fast DC charging stations, if it is there, means if it should transfer the battery SOC condition, then only this EVSC will start each condition, CCCV conditions, which stage you should have to charge the battery, that transfer data. And also in electric vehicle, if this want to pay the any amount, normally in normal pilot wire communication means this is the EV, right? EVSC, right? This is the EV. Once this charging is completed, here it should have to pay or QR code something, you have to pay it on a year. But in PLC, in internal vehicle details, car details, it will transfer to EVSC. Automatically it will detect the amount from owner vehicle owner card payment. So smart payment PLC wise, it will pay the smart way. So this type of advantages is there. One more advantage is that normally PLC communication, there is not in PLC communication normally CAN or some other communications, that separate wire communications should required. But for PLC, the separate wire is not required. The data will transfer from CP line, and normally this PWM's 1 kHz CP line is generate 1 kHz frequency. So in the above of this the PLC data will transfer above this PWM. So how this will eliminate in both sides, means EVSC side one PLC is there, EV side PLC. Here on band pass filter, that band pass filter have frequency range 1 to 30. If this EVSC transferred to this side, so this 1 kHz frequency data eliminate here. whatever the frequency range is there, right, that will transfer to EV PLC. Same way, this side also same way. So like that, so this data will eliminate, low frequency data will eliminate before this. After that, high frequency data, whatever the data is there, that data will transfer to PLC. After that reading, that data will transfer to MCU. Like this communication in between communications, it will work in between these two communication. Okay, so we can go to this here, what is that? PLC. Okay, PLC enables bidirectional communication between EV and charger. This communication ensures safety, efficient charging and negotiation voltage, current and charging conditions. It will negotiate. And by PP line monitors the physical connections of the charging cable. CP manages the charging station, ground, recharge and current capability. This is the standard to follow. 3 more standards is there. Normally I refer this to this standard. Okay, normally power and communications fundamental requirement is to enable smart and grid conversation in between EV and charging station. Before PLC, normally for analog PWM, power and communication, pilot wire communication is used earlier. So that time AC charging stations, without smart charging stations. Before smart charging stations, they used PWM communications. Okay, this is the PLC. So if you like this video, please subscribe, like and share and comment. If you want more information related to PLC and this more information related to PCB, PP circuits, how this will work and simulations and all, please comment. I will more in detail. I will do one video more in detail. Thank you.